Hello, and thank you so much for joining me today. This is the next video in Module 2, which discusses the research process. And in this particular video, I'm going to continue talking about confounding variables, and I'm also going to introduce the concept of extraneous variables. Okay, so just by way of review, I think it's important to re-emphasize what our objective is when we conduct experiments or when we utilize an experimental design. Okay, so the purpose of an experiment is to establish cause and effect relationships. So this is basically why experiments are the gold standard in psychology. It's because they allow us to think about causality, which none of the other research methods allow us to do, right? So what this means in effect is that experiments allow the experimenter to be certain that the independent variable and only the independent variable is causing change in the dependent variable. Okay? Okay. So confounding variables are present when there is some difference between your experimental and control groups other than or in addition to the independent variable, right? So said another way, confounding variables affect one condition differently than the other, right? So just like the independent variable affects the control group, but doesn't, or excuse me, just like the independent variable affects the experimental group and doesn't affect the control group, okay, confounding variables affect one condition differently than the other, right? So let's take a look at some examples. Okay, well, first of all, it's important to understand that there are two types of confounding variables, right? So the first type, and arguably the most common type, is individual difference confounds or individual difference confounding variables, right? So this is the same type of confounding variable that I talked about in our does breastfeeding increase intelligence example that I went through in my last video, right? So with individual difference compounds, okay, the sample of participants that you utilize in your experimental condition or your experimental group differs in some significant way when compared to your control group, right? So in our example that we just worked through, all of the children in the experimental group were from a university daycare, while all of the children in the control group were from a community-based daycare, right? So because of our individual difference compound, okay, we do not know whether the changes in the children's intelligence or the increase in the children's intelligence in the experimental condition is due to our manipulation of breast milk or whether something else that differs between our samples, okay? So is it due to breast milk or is it due to all of the participant characteristics that differ between the experiment and control groups, right? And so the way we fix this, like I said last time, is through random assignment, okay? All right, so let's look at some examples of individual difference confounds. So Dr. Stokes is interested in investigating whether money really does buy happiness. In the experimental group, a sample comprised entirely of women is given $10 for their participation. In the control group, a sample comprised entirely of men is given $0. Subsequent mood ratings reveal that indeed the experimental group is significantly happier. Can Dr. Stokes trust these results? Okay, so go ahead and pause the video and maybe jot down your own answer to that question. And I'll go ahead and pause here for just a moment. All right, so can Dr. Stokes? No, he can't, right? Because higher ratings in the experimental group could be attributed to what we manipulated, right? Which is the presence of a monetary incentive, or it could be due to gender, right? So for whatever reason, women could just be happier than men, right? Because of the way that this particular experiment has been designed and the way that we chose or Dr. Stokes chose his samples, right? We can't tell whether it is the variable that we manipulated or the independent variable or the characteristic that differs between our samples, which is in this case gender. Okay, so the second type of confounding variable is called a procedural confound. So procedural confounds occur when the procedure that participants go through in the experimental group differs from the procedure that participants go through in the control group in additional ways besides what the experimenter actively manipulates, or the independent variable, okay? And it's fixed by holding every factor constant except the IV, right? Remember in my brief example from my last video where I talked about a hypothetical scenario where you design an experiment for Nintendo that looks at whether video games increase happiness, right? So our IV in that case are hours of video games played, right? So we have 1 hour versus 3 hours versus 6 hours. Those are our levels of the independent variable, right? And I mentioned that the variable that can change is the hours in which the video game is played, right? But we would want to be very careful to hold constant the type of video game, right? And that's because we want to make sure that the experimental group or all levels of the independent variable, those three groups, are identical in every single aspect except what we're choosing to manipulate, which is the hours of video games that they play. Okay, so let's look at another example. So Dr. Stokes is interested in determining whether money really does buy happiness. He randomly assigns samples comprised of both women and men to the experimental and control groups. On the day of the study, due to the fact that many of the classrooms at Dr. Stokes University were overbooked, participants in the control group completed the study in a cramped, hot basement with no windows in exchange for $0, while participants in the experimental group completed the study in a large air-conditioned lecture hall with a view of the surrounding mountains in exchange for $10. Once again, Dr. Stokes finds that the experimental group is significantly happier. Can he trust these results, right? So we no longer have to worry about individual difference compounds here because he successfully utilized random assignment, right? But there's another problem here. And I'll go ahead and pause the video so you can go ahead and jot down what you think the problem is before I advance the slide. Okay? So go ahead and jot down in your notebook what you think the answer is, and I'll just chill out here for a second. Okay, so can he trust these results? No, he cannot, right? Because higher ratings of happiness in the experimental group could be attributed to the money, so the $10, the monetary incentive, or the environment, right? So the experimental group was lucky enough to enjoy a mountain view and air conditioning and a much more luxurious, pleasant surroundings as compared to the control group. Okay, so their increased happiness, certainly one explanation for that could simply be the better environment or the more relaxing and pleasant environment. So we don't know whether it's the monetary incentive or the environment in which they find themselves. Okay? Okay. All right, so now that we've talked about confounding variables at length, I wanted to introduce a related concept called extraneous variables. Okay? So like confounding variables, extraneous variables are going to alter or change the dependent variable. Okay? So they're just as bad as confounding variables, okay? Because again, we want the only thing exerting an influence on the dependent variable to be the independent variable, right? But unlike confounding variables that affect the control group and experimental group differently, extraneous variables affect both conditions in the same way, okay? So let's look at an example. Okay. In Dr. Stokes' study, if both the experimental and control groups were placed in the hot, cramped basement, subsequent mood ratings would be lower for both groups. Okay? So we would expect ratings of happiness to be reduced for both groups instead of affecting the experimental group more profoundly. Okay? So we would expect to see the same drop in mood for both the experimental group and the control group. Similarly, in the breastfeeding IQ study that we talked about in my last video, if all of the children were taken from a sample of university parents, okay, IQ scores would be higher in both the experimental and control groups. Okay? So, like confounding variables, extraneous variables induce a change in the dependent variable, but unlike confounding variables, they affect both groups equally. Okay? All right, so that concludes this video talking about extraneous and confounding variables. Certainly, if you have any questions, you're more than welcome to contact me. I hope you're having a fabulous day, and I look forward to seeing you in my next video.